Welcome to Inside AFIMSC, a new podcast dedicated to bringing you news, information from our leaders, experts, and teammates. I'm Veronica Kemeny, your host today, and I am joined by Dr. Craig Rutland, who is from the Air Force Civil Engineers Center, and he is a pavement subject matter expert. Welcome, Dr. Rutland.
Thank you. It's good to be here.
So tell our listeners, what does a pavement SME do? What do you do every day?
Well, our primary focus is making sure that we have standardized guidance on the design, construction, evaluation, repair, rehabilitation of airfield launch and recovery surfaces. And we do that not only with pavements, but we also do it in relative to what we would call unpaved surfaces, things like dirt airfields, landing zones, and mat airfields, where we're using AM2 mat that many might be familiar with.
And this is important because we have all kinds of aircraft flying in.
Yes. It really comes down to interoperability. We need to be interoperable with respect to the aircraft and missions that we have within the Air Force. We need to have it within DoD. And to a larger extent, we need to be interoperable oftentimes with our international partners.
And explain to listeners, because I've just followed you. We went to Der Bosch, the Netherlands, to a NATO airfield pavement conference. And then I followed you to Mildenhall to look at an actual airfield where some testing was done. And explain to our listeners why airfields are important and things that they need to think about, because there's big airplanes, there's the heavy airplanes, the fighter airplanes,
yes,
and they do different things to asphalt and concrete.
Correct. I guess the focus of what we were doing again is to become interoperable in all that we do, and that part of that was that international focus of teaming with our NATO partners. At these meetings, we develop standardization agreements as well as standardization recommendations. Some of those, the agreements are binding, and as part of that agreement, that may in fact affect the criteria and specifications that we utilize. So as a part of that, our agreements, we might decide to do the design a particular way or design pavements to behave in a particular manner or have a particular lifespan. All of that ends up in our criteria as our means of implementing these agreements.
And just to let everyone know, at the airfield pavement team meeting, we had the Netherlands hosting us. We had the UK there. Mm-hmm. France was there. We had Greece there, Turkey there. The Army was there. The Navy was there. And to explain to everyone, again, you're coming up with these, you call them how do I say that word?
STANAG.
STANAGs.
Which stands for Standardization Agreement.
So that if I bring my airplane from the U.S. and land on your airfield in Greece, I know what's happening at your airfield, and you're ready to receive my aircraft.
Correct. And again, the big issue that we run into oftentimes is that it's not that all of these countries haven't seen aircraft. They all have them. They all have high performance aircraft. But as we develop newer technologies, they tend to push the envelope of what those pavements were designed to be able to handle. There's a rather famous or infamous, if you will, video from 1941 where the newest aircraft to the inventory of what was the Army Corps, Air Corps, rolled off the assembly line in California. It's the XB-19. You could probably Google that and look at it.
Right.
The video. No sooner had it rolled off onto what was a an unpaved tarmac, and it sank several inches into the prepared surface, and everybody realized, we can't just use. Up to that point in time, everybody had just simply used criteria that had been used for roads.
Okay.
And it was
an airplane is very heavy.
Correct, and so they realized that at that point in time they were kind of pushing the envelope, and it was really at that moment that the birth of airfield pavements occurred. I mean, that's the point in time where they realized, we got to do something a little different.
Such interesting history. And so what is an average length of a runway that we're looking at, and cost of a runway? You're looking at this every day.
Yeah, we have some landing zones that can be as short as 3,000, 3,500 feet. We have our longest airfields are on the order of 12,000 linear feet. I think we may have one that's 13,000. And the price varies. If you were to just have a landing zone and nothing more than just a landing zone, i.e. a runway, and it were asphalt, you could probably get by with resurfacing one for about $10 million. We've had a few where we've done some resurfacing of a minor portion of it, if it was just a mill and overlay, on the order of $1 million. Typical pavement that you might do a highway with, most figure about somewhere between $2 and $5 million a mile for a highway.
And you're trying to, in your job, preserve and get longevity out of these airfields as well.
Correct. One misgiving, I guess, or misconception that folks have is oftentimes they're very focused on the compressive strength or the flexural strength of the concrete or the pavement. And obviously on a flexible pavement, that's not really what gives it its strength. It's the asphalt or the flexible pavement is really just there to protect the load-bearing system, which is, in fact, the stone base and sub-base material. That's really what holds the load. So
the engineering behind the
yes,
airfield.
Yes. And then in the case of the concrete, it's there to hold the load. And while flexural strength is important, quite frankly, I'm more often replacing a pavement not because we have exceeded its design life from the standpoint of the number of passes or its ability to hold loads. It's usually damaged by environmental effects, i.e., and a lot of those are engendered by defects in either the materials or the construction methods, and in a few cases the design. They may have too wide of a joint spacing, or they may use the wrong types of joints.
And when we went TDY to the Royal Air Force Base Mildenhall, you were looking at a product they'd applied to the airfield to make it stronger. Because some of the things that our listeners may not know is that if an airfield starts to crumble, there's FOD issues that could impact an aircraft engine and, do bad things to it. So tell us what we were looking at there. It was so interesting.
Yes. Well, as I mentioned before, the reason we're constantly having to have these meetings and discussions is that we're always pushing technology. We're making changes to the aircraft. Well, we've introduced several aircraft that put much higher heat loads on airfields than we have seen in the past. And we were around the Osprey, yes, which was beautiful. Yes. And I guess they take off... they can take off vertically. They can also take off in a horizontal manner as well. Okay. But the essence of the issue there is that their engines or nacelles can rotate, and when they do, and when the engines cool off, the seals tend to give way a little bit, and so now all of a sudden you have petroleum products, POL, that might drip out of the aircraft. And so once they hit the ground, if it's concrete, it tends to get absorbed into the ground. If it's,
and we're always trying to be environmentally conscientious as good stewards.
But in the case of concrete, it has, aside from the environmental effects, it also has an effect where the petroleum products over time can actually chemically change into acids, and
to kind of ruin
it will actually eat the concrete up from the inside out.
Okay.
Because concrete is, by its very nature, a very basic. It's a base, and as you know, when you put an acid with a base, you have a chemical reaction that creates a salt. And
Engineering 101.
Yes, chemistry, basic chemistry.
Okay.
So the essence of that issue, though, is that we compound that with the added heat. I mean, we've had aircraft that have POL get on the pavements all along, but it's that added heat that every 10 degrees Celsius, I'm doubling the reaction rate. So when I'm putting heat onto the airfield, and these nacelles rest about almost 18 to 24 inches off of the ground, the temperature at the exhaust is 500 degrees.
It's pretty hot.
Yeah, so it's mighty toasty right there on the surface. And so you can imagine that it would increase the rate of that deterioration significantly. If I'm doubling it every 10 degrees, then I'm hundreds, if not thousands, of times more. The reaction occurs thousands of times quicker than you would see if you just simply had some POL that got on the ground.
And from what I saw, Milton Hall is a busy airfield. They fly, it said over 1,000 missions every month, and it was tankers, Osprey, and all the guest aircraft.
Yes.
So they were so busy. That airfield is constantly used. And we met with Tony Lawrence, he was a British civil engineer that supports the squadron there. And you've actually had a relationship with him for quite a long time. Yes. And it was the first time you'd ever met. And he was thrilled to meet you.
Well, yeah, we had corresponded and had phone calls probably since somewhere around 2004-ish.
That's a long time.
Yes. Back when I was still in uniform.
Okay.
And then, but of late, we've been corresponding on this particular project. When the Ospreys were being looked at to position there, and we've been looking at, again, methods that we can utilize to treat the surfaces of the concrete so that we can keep that concrete in good condition for much longer. There was kind of a perfect match. A little bit of background to the coating that we used there. In a couple of meetings of that NATO APT, I had met with my UK counterpart, and we had some discussions about some products that they were using and had been using
exclusively in the UK.
Yes, and they had been using for many, many years. And the subject of that coating had actually come up with a NATO project that we got involved with in Poland, of all places. And so we were asked to do some work in Poland, some rubber removal. Well, somebody had used that product on the surface, and so I was being asked, well, is the rubber removal equipment and operation going to cause a problem? And not being familiar with the product, I called around to try and find some folks that had used it, and ran into my UK counterpart who mentioned they use it all the time.
Oh, that's great.
They had been using it for about 20 years, so
And successfully from
yes.
our TDY. I saw that.
Yes. So, yeah, we've looked at that product as well as some others. Again, it's trying to